Today is day 3 in section 5-6. This time we're writing equations in slope-intercept form still, but today we will only be given 2 points that are on the line. Please title the top of your notes. Okay, so let's talk about some steps today to writing an equation in slope-intercept form when you're only given 2 points. Remember, prior to this lesson, we've done it when we're given a point and the slope and the y-intercept, and we've done it when we've been given the slope and a point. Now, again, today, we're just given 2 points. So the first thing we're going to do is calculate the slope. We know the slope formula. We'll do y2 minus y1 over x2 minus x1. And once you've calculated the slope, then we're going to use the first point and the slope to plug into the equation again, because we still have to calculate the y-intercept. Once we've done that, then we will write the equation using both the slope that we found and the y-intercept. So the only new part today is that we have to calculate the slope first. So it's not given to you like it was yesterday. So let's just look at some examples. So again, writing an equation in slope-intercept form given these 2 points. What this means is that our line crosses through those 2 points. If I plotted those 2 points on a graph and I drew a line through them, that would be our line of the equation that we're about to write. So first we're going to calculate the slope. Remember, when we calculate slope, it's y2 minus y1, so that's 9 minus 4, over x2 minus x1, which is 6 minus 3. 9 minus 4 is 5. 6 minus 3 is 3. So our slope is 5/3. Now we are where we were yesterday. We have the slope and we have a point. We actually have 2 points. So we're going to write slope-intercept form, plugging in those 3 pieces. We need to plug in an x and a y, and we need to plug in m so that we can solve for b. Now, in this case, it actually doesn't matter what point you use. I will always use the first one. It's consistent, so I always pick the first point. So remember, from the first point, the y coordinate is 4, my slope is 5/3, and the x coordinate of that same ordered pair is 3. It doesn't matter, again, if you use the first or second ordered pair, just don't mix them. Okay, if you're going to pick the x from the first ordered pair, you also have to use that y. So when we multiply a whole number times a fraction, we can cancel, those 3's cancel, and so we just get 5 plus b. I'm going to subtract 5 from both sides. So now I have b equals -1. So we're going to use the slope that we calculated and the y-intercept that we calculated to write the equation. Y equals 5/3 x minus 1. This is the answer. This is the equation for the line that goes through those 2 points. Okay, number 2, we have the points 4, 9, and 8, 4. So when we calculate our slope, we're doing 4 minus 9. Remember, that's coming from that y2 and that y1. 8 minus 4 is coming from x2 and x1. So that's -5/4. Plugging in the point, one of the points and the slope into the equation. So I'm going to use that first ordered pair. So 9 is the y. Slope is -5/4 times the x coordinate of my ordered pair, which is 4. So 9 equals, again, those 4's are going to cancel, -5 plus b. If you're not understanding why I'm canceling the numerator or the denominator with the whole number, when you multiply a fraction times a whole number, the trick is multiply the numerator by the whole number. 5 times 4 is 20. And then you can divide by the denominator. 20 divided by 4 is 5. Add 5 to both sides, and we get a y-intercept of 14. So now again, I'm going to go back and use the slope I calculated and the y-intercept I calculated to write my equation. Y equals -5/4 x plus 14. there is the equation of the line that goes through those 2 points. Number 3, we've got 5, 0, and 0, 7. Lots of zeros. That will make this one a little bit easier. So we calculate the slope. It's 7 minus 0 over 0 minus 5. Pay attention and make sure you're going in the same order so you get the correct sign. This is 7 over negative 5, or that's the same thing as negative 7/5. I prefer to write my fraction with the negative in the numerator versus the denominator. So now we have y equals mx plus b. I also like to write the equation so that I know I can see what pieces I'm plugging in. I'm going to use this first ordered pair. So my y is 0. My slope was negative 7/5, and I'm going to multiply that by 5, which is the x coordinate of the first ordered pair. 0 equals negative 7/5 times 5. Again, those 5s are going to cancel. This worked out kind of nice, didn't it? Negative 7 plus b. Now we're going to add 7 to both sides. So 7 equals b. Now some of you might maybe have recognized, or you're going to understand now, when you have an ordered pair, a point on a line, and the x coordinate is 0, the y coordinate is your y-intercept, right? We know that y-intercepts happen when x is 0. So in a case like this, where one of the ordered pairs had a 0 for x, we actually already knew what the y-intercept was. We could have maybe saved ourselves some time from doing all of this math, but that's okay. I wanted to be able to show you that you do still get 7 when you calculate it using algebra. So now the answer, y equals negative 7/5 x plus 7. I think I have one more example. This might be one where the fraction doesn't cancel, so we get to kind of work with that fraction again. So negative 1, negative 3, and 2, 9. So first the slope formula is 9 minus negative 1. That's going to be adding. And 2 minus negative 3. Oh no, this one works out real nice. 9 plus 1 is 10. 2 plus 3 is 5. That gives me a slope of 2. Always reduce these right here. Don't go into the problem and try to work with 10/5. That's just, it's a fraction for one, but it's also not reduced, so you're going to be working with bigger numbers. It just makes it easier if you reduce it right here. So using that first ordered pair, plugging in my slope and the point into slope-intercept form, I get negative 1 equals, my slope is 2, the x is negative 3, plus b. So that's negative 1 equals negative 6 plus b, adding 6 to both sides. And we get 5 equals b, or b equals 5. So now my equation is y equals 2x plus 5. Remember that 2 is coming from the slope we calculated, and the 5 is coming from the y-intercept we calculated. Okay, so that's how you do it. That's about as difficult as these equations get for writing them in slope-intercept form. We can write them off of the graph because we know the slope and the y-intercept. Those are the 2 pieces of information that you need. And now we've spent several days doing it algebraically. So remember, you've got to have the slope and you have to have the y-intercept in order to write an equation in slope-intercept form. I'll check your notes and we will work on worksheet 5-6C.